So we're going to continue reviewing for the final exam, and make sure I got my mic turned up. Okay, so let's continue on number 10. We got two groups, and we want to see if the mean between the two groups are the same or if they're different. So to kind of visualize what we got a group of metal bars from the experimental group, and we got a group of metal bars from the conventional group. So we'll call this the experimental group, this the conventional group. And we don't know if the bar strength is the same or different. So what do is we take a sample from each one. We can compare the sample. Once we take that sample data and compare the two, then we can make an educated guess about the population data for the two types of metal bars and their tensile strength. Okay, so let's read the question carefully, see what we got. An engineer wants to know if producing metal bars using the new experimental treatment rather than the conventional treatment makes a difference. So they want to know if it makes a difference. If it makes a difference, that means that they're not the same, right? So that's what we want to test. That's the claim. The alpha value is 0.20. Assume that the population variance is equal. That's going to be important here in a second. The population variance is equal. All right, and then they give us the sample data. So let's see, the claim is, so this is the claim. The claim is that, what? There is a difference. If there is a difference, it means that they're not equal. I got that straight from the problem. Makes a difference. So the null hypothesis is that, remember the null hypothesis always has a statement of equality. The alternative says that they're not equal. So what's the claim? If it makes a difference, that means that they're not equal, right? So if they're not equal, that means that the claim is the alternative hypothesis. If it makes a difference, they're not equal. Now it says, well, what's the critical values? Well, remember for critical values, what you need is you need the alpha value. They told us the alpha value. My alpha value is 0.20. That's given. And you also need to know the degrees of freedom. And here's where it makes a difference on whether or not the variances are equal or not. So if the variances are equal, like we have here, what we can do is we can take the two sample sizes and pull them together. In other words, combine the sample sizes. So we take the sample size. Let's see the sample size of the experimental group. We got 1, 2, 3, 4, 5, 6, 7. Let me count that again. 1, 2, 3, 4, 5, 6, 7 from the experimental group. And now we can add the sample size from the conventional group. We got 7 plus 3 more is 10. We can add those together, but then we have to subtract away 2. Not 1, but 2, because this data came from two groups. So we got 17 take away 2, which is 15 degrees of freedom. Okay, so we should be able to do that and look at our critical value table. Let me get the critical value table. All right, so here's the critical value table. We got two tails since it's not equal to. Two tails, alpha value 0.20, 15 degrees of freedom. So let's see what we got. 15 degrees of freedom, two tails, 0.20, 1.341. All right. Thank you. Two tails, 1.341 and negative 1.341. All right, so they want that rounded to 3 decimal places, plus and minus. You can use that plus and minus to save yourself a little bit of time. We got positive and negative 1.341. All right, so that's good. Now, where's the rejection region? Remember, we reject the null hypothesis out on the tails. So that's where we will reject the null hypothesis. So anything greater than the positive or less than the negative. That's what this says, right? Less than the negative or greater than the positive. That's perfect. And now they say, well, now let's find from our sample, right, from these samples, how can we take those samples and convert the sample into a t-statistic? Take our sample t-statistic. Well, let's upload our sample into StatCrunch. Here it is. And we will go to stat, t-stats. We got two samples here. And we actually have the data. They actually gave us the data there. Our first sample was the experimental treatment. Second one was the conventional treatment. And we did pull the variances, right? Be careful there. Pull the variances because the variances are equal. All right. And we're going to do a hypothesis test. The hypothesis test looks good. The difference between the two is 0. The difference between the two is not 0. So it looks good. Let's compute that and get the t-statistic. Very small t-statistic there. 0.162. So it's barely off that 0 mark. That 0 mark says that there's no difference between the two, and it's barely off that. That t-statistic is right there. So we're going to fail to reject the null hypothesis. All right, so let's finish it up. They want it to the nearest thousandths. That's 3 decimal places. 0.162. Let's see here. Let's go back to StatCrunch, make sure I wrote it down right. 0.163 when you round it correctly. Okay, just make sure you round right. 0.163. Okay, that was in the fail to reject region, right? That test statistic from our sample was in the fail to reject the null hypothesis region. So what can we say about the claim? Well, the null hypothesis, remember, the null hypothesis failed to reject. The alternative hypothesis then gets the X, and the claim was the alternative. So anytime we have an alternative hypothesis for our claim, we're going to use words like support or don't support. So in this case, there is not enough evidence to support the claim. All right, that's good for number 10. Let's see what's going on with number 11. We got to match up the scatter plots, age and body temperature. The age shouldn't affect the body temperature at all. The body temperature should just remain constant. So that's what's going on here. Age and balance on student loans. Notice where the age starts off. The age starts off in like your early 20s. So at your early 20s is where most people start getting out of college. So your student loans should be going down because hopefully you're paying those off. Okay. Now what? Age and income. Hopefully your income goes up the older you get. Age and height. Well, that's really no relationship at all. It should be, especially after your mid-20s, your height should be about the same, not going up nor going down. All right, so that should do it. Number 12, they want you to get a regression equation. Well, that comes from uploading the data into StatCrunch. So this equation will relate the y value given an x value. It will tell you your test score based on how much you study, or at least an approximation of that. So how we do that is we go stat, regression, simple linear, put in your x, put in your y, and you should be good to go. There's my equation. So I'll put in my slope first. The slope is the number in front of x. So there is the slope. I'll copy and paste that in. That's the number in front of x. And then next, my y-intercept. That's the number that's not in front of x. So that's this guy. I'll cut and paste that in. Okay, careful here. Round the slope to 3 decimal places. So I'll try to be more careful on this one. That goes up to an 8. And round the y-intercept to 2 decimal places. Okay, well, there it is. Now, what did our scatter plot look like? We can go back to StatCrunch, scroll over to the right and look at the scatter plot. Looks like the scatter plot is increasing. Half of the dots are above, half the dots are below. I'm sorry you guys couldn't see that. There it is. Okay. I feel bad that you didn't see the slope and the y-intercept, but there they are, right? Test score y equals. In this case, they have y equals the intercept first, and then the slope second. But that's where I got it. Sorry you couldn't see that. But anyways, there's my scatter plot. It's increasing with half the dots above, half the dots below. So that's this one. And now I can use that equation and plug in my values. Now be careful, make sure that your values are within the range. So first they have you to plug in a 2. When you plug a 2 into that equation, you can plug that into your calculator. StatCrunch does allow you to do this fairly easy. Let me show you how. Actually, let me bring that over here. So if you go to StatCrunch and go to Edit, and you can edit that and go to Prediction of Y, put in those X values that you want to predict. So when X is 2, separated by a comma, 2.5, separated by a comma. I'm not going to do 12. 12 is not inside the X values that were given. And then we'll go 4.5. 12 was too big. All right, so look what we got. Scroll down. When X is 2, we got 46. When X is 2.5, we get 49. When X is, 2.5, it's 49. When X is 4.5, it's about 62. So I'll try to remember that. 46, 49, 62. So that's 46. $49. 12 was too big. Look at your X value. See how the largest X value is 6? 12 is outside that range, so that's not going to be meaningful if we plugged it in. It's outside of our data set. 4.5, I believe, was about 62. All right. That brings us to problem 13. Let's see, how long has this video been going on? About 14 minutes. Good place to stop. We'll finish things up on the next video. Talk to you then.